do like a tester and like sit down and do it.
Oh, sure. The mics. Should we use mic?
Yeah, let's use mics because I feel like the AC is I feel like it's more. I don't feel like.
No, I haven't sat down yet. Oh yeah, like this. Look, it's perfect.
Okay, I think it's good. Oh, actually, I'm gonna quickly go for that panel.
Okay, I need some pee actually.
Okay.
So we can turn it off and then.
No, I think we should try it with let's try it with a microphone and then.
Okay.
Start afresh. Oh yeah, like what kind of stuff do you want to talk about? And so I was gonna say I want to hear all about your. After.
Oh, I've literally been so busy.
Look at you guys. What's it called? Entrepreneur engineers.
Entrepreneur.
Entrepreneur engineers.
Entrepreneur.
Yeah, entrepreneur.
Yeah. I don't know. I haven't really been focusing on that for the past week. I was on holiday actually. I went
in Spain. Wait. What languages can you speak?
I can speak Spanish, a little bit of Spanish. I can speak 4 languages: English, Hindi, Gujarati, like conversational. Like I can find my way around, and I think if I stay there, like for a month, I would definitely be able to actually speak the language. From school, like.
Okay. For me, that's French then.
Yeah.
Oh, that's so cool. Do you want a banana?
No, I'm good. I have apple.
Oh.
Thank you.
Oh, what was I gonna say? Oh, that's so cool. Wait, Hindi and Gujarati?
Yeah, they're pretty much. They're actually not that similar, but they're.
I was literally searching up the other day, like Sanskrit. Is that the same as either one of these two? Because Sanskrit is a written version of something.
No, Sanskrit is the written version of. Actually, when it's spoken, is called something. It starts with a D.
So it's not Gujarati or Hindi. I thought Hindi was like Hindu as in a religion. I didn't realize it was like a whole language.
Yeah, Hindi is like the national language of India is Hindi, which is derived from Sanskrit. So Sanskrit is actually, when it's spoken, it's called Devanagari.
I've never heard that word in my life. Yeah, testing. I love how we just started talking.
Oh yeah. It's basically like the oldest. It's older than Latin, so technically it's the oldest language.
You've never heard anyone speak, because like with Latin, people can be like, "This is what it sounds like," and be like,
"No."
Est something. But Sanskrit, which is why like I feel like it's just a written language, because like no one speaks
it anymore. That's why. So it's one of the earliest, earliest languages.
But if it's only written, then we wouldn't know how it sounded anyway. We're just making it up.
No, because it's like Latin. It's like you know how A's and B's and C's sound, so you can kind of. It's not actually the same, because in Hindi the alphabet is completely different. So it's
so it's still alphabet you can understand.
Yeah, the alphabet in Hindi is more phonetical.
You know what I'm saying? The alphabet of Sanskrit.
Yeah, because it's still used in Hindi.
Oh,
so the alphabet is
so the language is gone, but the alphabet's still there.
But it has so many different. So basically, in India, you have 27 states, right? And so you have 27. So you have national language, and then you have each state has its own language, and then you have regional languages. So within India itself, you probably have like 50 different languages.
I was gonna say like in Nigeria, it's like 800 and something like this. It's ridiculous.
Like, yeah.
Each state. Oh yeah, go on.
Because regional languages is such a thing. Like every culture, every little. Because states are huge.
I understand exactly what you're saying. Exactly. This is the same in Nigeria.
And then, so yeah, a lot of they're all derived from Sanskrit, which is the root
of Hindi
language of Hindi, which is like, yeah, basically. And Sanskrit is. So you know how English is not always 100% grammatically correct?
What do you mean?
A lot of stuff grammar-wise doesn't make sense in English. I can search up
examples.
I can search up examples.
I thought you meant word-wise, like you know how, water is like A and then T, but you can have another one like hater is a different pronunciation to water or something.
It's not that. It's the way that the English language just finds easy ways, because the reason Sanskrit is so complicated and so hard to learn is that each tense, each little change in tense or noun or verb has a completely different way of saying it. So it's almost as like, you know how in Japanese every little stroke has a different meaning.
I wouldn't really know, but I assume,
Yeah,
because I don't know Japanese. I know how it's said, but I
yeah.
can't read Japanese.
It's like, it's hard to describe it.
So
But
what I'm hearing is kind of like, if I wanted to say I was and I am, it would be like two different words. Like, it wouldn't be so close that you'd be able to tell what it is. Maybe I was is like a blue table, and I am is like a red airplane. Like, they're different
So-
enough that you wouldn't be able to like understand.
if I wanted to say,
you can speak
I am
Sanskrit.
walking through. I used to be able to. I really, really want to pick it back up.
How did you learn?
In school. My school used to teach Sanskrit.
Where?
Because I went to a Hindu school, like a Hindu faith school for the first like from 7th to 11th. So
in the UK?
for my secondary school. Yeah.
Whoa,
It's like one of the first Hindu faith schools. Yeah.
That's so cool. I guess to be fair, that school I went to, God, it was so many like Latin and Italian and Spanish. And we did that completely because I knew it.
Why? Did you move after?
Wait, so Gujarati and Hindu. So is it like they both Hindu as different states?
Yeah, so Gujarat is a different state. Obviously, Hindi is the national language. And then, yeah, there's different dialects of Gujarati. There's different ways of speaking it. A lot of Gujaratis actually moved to Africa, like Uganda, Kenya, Zambia. So there's an African dialect of Gujarati as well, which like kind of mixes Swahili and Gujarati. And so it's like there's so many different.
That sounded like the reason why I even got into this whole thing is I'm really trying to learn Arabic properly, as in like because like obviously I knew a bit already from university and stuff, but like I really want to be able to like understand it. And then I was like searching Arabic and like literally what you were saying about like Indian stuff, I found out about Arabic. So it was like the classical one, which is the one that's in the Quran, and then they have like standard Arabic, which apparently is like the one that everyone should be able to understand. And then you have spoken Arabic, which is one that has different dialects. So Egyptian Arabic would be different from Moroccan Arabic and all that stuff. So I'm trying to learn classical, but I also think it would be useful to learn the standard one. So the way he described the video I'm watching, the way he described like standard Arabic would be like, you know, if you read a newspaper in English from the UK and you read like a newspaper in English in, for example, Nigeria, or you read it in any country that has English as its national language, would all be the same because they put in like the same public rules. But if you wanted to speak, for example, English in Nigeria, pidgin English, obviously it's like formal language, or like English in a different place, they'll have like or like I think they call it like there's like a Malaysian English mixed in that. But yeah, it would be different. So it's kind of like what you're saying. And I feel like I guess with the languages that I know, which is like I'm realizing that for French because like I'm trying to take learning language seriously, and then I realized all this other stuff. I'm like, okay.
Languages are so cool. I honestly, if I had one superpower, I think it would just to know every single language in the world. Like, how like insane would that be?
It would be very cool, but if I could have only one superpower, I feel like that wouldn't be it though.
Really, or to like be able to read really fast.
You can have I guess we're already starting.
Yeah.
I have a post about this one medium, like what's the best superpower? Because like
Yeah.
I was applying for this like job, and like you have to like work in your presentation skills, so they asked us to do a presentation, and they had like a variety of topics, and I chose that one. And maybe my answer is convoluted. My answer is like to be able to. It's ultimate knowledge. You want to be able to like know everything.
Yeah.
That's the answer.
But would you be able to? Yeah.
But the thing, like I guess the caveat there is like, would you be able to do everything? The answer is no. As long as I know everything, I can instruct people on how to do the thing. So, like for example, like when I was talking about this, it was kind of like I thought about the answer, or I was thinking about what my answer would be like. You know, I want to be this, for example, like time travel, whatever it is. You would know how to do everything. Maybe in your life you wouldn't be able to. You would know how to do. You'd be able to like instruct people on how to do it. This is how it would be done. Like, you don't have to be able to do everything. You just have to be able to know everything. And then the doing part, other people can do it. And even like the language, if you know everything, you would obviously language is obviously like subsumed.
would you be able to live knowing everything though? I don't think as a human being
You mean like my
in
brain
your
would
brain,
explode?
not you'd have to have insane self-control. You'd have to have
That's the whole point of it being a superpower. Like it can happen. Because like people say superpower like being transparent and stuff like that. Like if you think about it, like really be, but like if we're allowing it to happen, like my brain can explode and I have all the neurons needed, then that would be the best superpower.
like have you there's this like that's true. There's this like book I want to read it. I was hearing about this somewhere. It's called like The Link Between Genius and Madness or something.
Okay, I don't know if this is a book, but
That's
like, I
so
searched that so much because every time I'm going through like
yeah.
I'm a genius.
Yeah, I'm a star. Exactly. It's true though, don't you think?
Is it really? Because like when I was searching this up, it's kind of like apparently it's kind of one of those like fallacy things where I think like the quote that made me even go down this rabbit was like genius is the mezzanine layer between like madness. Or something else that was like first floor and like down to like it's the sweet spot between madness and something else. Was it intelligence? I don't know what it was. But it basically got me thinking, and basically I read this whole article where it's like we shine the light on the people who are like it's kind of like the people who are talking about like with beauty and like women will be with the men just because we see more of one side. But essentially, yeah, people talk more about the people who are like I don't know what examples were used. I think it was like sure Einstein was there.
Yeah.
There was someone
Van Gogh, Da Vinci, Newton.
Yeah, but these are like if you list them all, maybe max 10 people. No one's talking about the people in psychiatric homes who are not no level of genius. Like the link is what we want to see because we only shine light on the people who are like, oh yeah, they were a bit crazy, but they were genius as well. But no one's talking about the several people who are just mad or the people who are just genius. People shine the spotlight on like the people who are both, and it's kind of like, yeah, but is it?
But the people at the top of genius, right, are both.
Really? Okay,
Really?
wait, let's list. Okay, so let's list geniuses and then we say Stephen Hawking. I don't think he's got any level of madness to him.
Have you? You're reading his book.
Yeah. You think he's mad?
I don't think he's mad.
You think he's teetering?
Imagine your body is not functioning. You're instantly deteriorating as you speak, and the only thing you can think about is black holes. The only thing you can think about is defining this universe. The only thing you can think about is physics, and I want to go and I want to give lectures, and I want.
But that's the things that we know him to be famous for. This guy he has children. He has.
Of course, he has children.
I don't think all he does all day is sit and think about black holes.
No. Sag Lichter.
Do you actually need the charger?
Maybe they keep dying.
Okay. Yeah, I think they keep dying.
Okay, I think they're
Hello,
dead.
hello. Oh my god, it died again. Yeah, it showed red. Mine showed red. So I think it's actually dead. Okay, it's showing red. Do they have cables in there?
Mine is red too.
You can just plug into your laptop. Like we can actually like be charging it now, because then we know by next time we'll do it.
Yeah.
We can still talk normally. If the audio is bad, then guess what? It's bad.
Yeah. But oh yeah. So I was. Oh, what I want to talk about was how. Yeah. I was listening to this video where it was like talking about parallel universes, but not really parallel universes. It was talking about if you woke up this morning and turned right when you left your house, then there must be a version of you that turned left.
I don't. Yeah, go on.
Yeah, and then there's all these different like versions of you who've done things differently. Kind of like that. There's infinite. Then there's infinite versions of you, right? Who've taken these infinite possibilities. But the thing is, if you take one possibility, you have to take the rest, because that's how the universe works. If you turn left, then you have to turn right. No?
That's the part that I didn't get. So it was like, there might be a version, but you said it's not parallel universes. It is parallel universe.
It is parallel universes.
Yeah.
That's how they work. Yeah.
Oh, that's how people describe
That's
it
what-
in
yeah,
science
yeah.
fiction. But what you were saying is like, I don't get the whole if this then that. I don't get that.
I guess maybe it's going off like Newton's like every action has to have an equal reaction.
So if the reaction of me stepping on the floor gives
It's
you
a
opposite
ground
reaction, it doesn't mean
That
if I go down.
Yeah. So I don't know why.
No, people give that as a theory in like science fiction, but I am yet to come across like the time travel thing. Explaining the British history of time makes sense
Yeah.
in terms of the way of viewing it. It's like,
Like.
if there was like a black hole, what does that say?
Oh, it's just like.
The best for you in every. Oh. What was I going to say? Oh yeah, so in the light thing, and like if you have a wormhole, it makes sense that you should be able to go forwards in time, but not backwards in time. And then the thing about like, because like the whole antiparticle thing was like you can see or you can view, like two antiparticles meeting together as one moving forward in time and the other one moving backward in time. And then there was another thing he explained about.
That's crazy.
Something else. You can view it. You can. You can view it as that. And there was something
Isn't
else
that what won the Nobel Prize a few years ago?
I don't actually keep. I think like back in six when like the Harry questions, like I probably used to keep up more like who won the Nobel Prize. Like
Yeah.
I can't tell you for the life of me
Yeah.
who won the Nobel Prize last
No.
year for what.
I just remember this was a big one because it proved that two particles, if you split an atom and you, even if you put it apart, particles will mimic each other or something, they can still interact.
Oh, that's quantum entanglement.
Yeah, that one. That was a huge one. Also, the article I sent you, it's on my phone, but it
I need
basically,
to read it. Please share.
I was like, it basically talks about, when I was reading it, it was basically, went into this deep dive about parallel universes, right? And then I was like, I need like someone to explain to me. I need a proper explanation. Like, you can't tell me this.
Yeah. So what was the explanation you came up with? Is that the article?
There was so much to wrap my head around. Let me see if I can find it.
No, but it's not the article you sent me.
Which one? No, the article I sent you was, that's not about parallel universes, but it covers the concept that I wanted to talk about, which was I'm trying to find that.
Fine, yeah, I'm gonna have to reply.
Reply.
My God.
Oh, here. The future causes the past. That one. Oh, that was insane. It basically talks about this all at one model.
It's the one you said.
Yeah. How the past and the future influence each other in a mutual and reciprocal manner, and therefore in such models, it's natural to expect that there will be correlations which appear from our internal point of view to involve something like backwards in time causal influences. How it's so when I was reading through the whole model, it just kind of blew my mind. It was talking about how Einstein called spooky action at a distance. When he was talking about correlations between measurement. Yeah, it's basically kind of more research on quantum entanglement.
I don't see how that has to be in time. They were both made at the same time. How could one age without the other unless?
What do you mean?
Let's say these are two. I'm going to give it a try to be separate. They're going to be revealed at the same time. Or if you reveal one, then stop revealing the other one. Sorry, if you reveal one, that means you know what the other one is. So that means you've read into the future.
I don't understand. I don't understand the theory that well. It's theoretical physics.
I was going to say I haven't read it yet, but it's kind of like if we can't travel back in time, or there's no way to be able to travel back in time, or maybe we just haven't figured it out. Then how
It's basically talking about how, like, obviously Newtonian physics and quantum physics, they don't correlate, right? Which is like the two basic theories of physics don't make sense together. Like quantum.
There is not a unified theory.
Yeah.
Is it GUT grand unified theory?
Yeah, so quantum mechanics, quantum physics, great in the quantum realm, and also great at like really large scales, right? It works at kind of
I don't
both
think
scales.
it works at large scales.
I thought it worked at really small scales, like Einstein. His general theory of relativity at really, really large scales, and
But
his quantum,
that's not quantum.
but then his quantum theory of relativity at really, really small scales. They both make sense. They both kind
You
of
don't
follow
have
the
a quantum root theory. There's like a special theory of relativity and a general theory of relativity. The
Yeah.
special one has to do with like light and the fact that the speed of light has to stay the same regardless of any observer. But
Yeah.
what that means is like space has to change, and then the general theory of relativity has to do with gravity, and it means that if it's like if light is moving across something like I was gonna say like that's one of the things like in the brief history of time. There is yet to be a theory of or quantum theory that includes gravity in a way that makes it unified, and conversely there is yet to be an explanation of what we see in the quantum scale for what Einstein did, I believe. Something about there not being a unified one. So I understand what you mean there.
Yeah,
but
yeah.
what's the key thing about
Basically, this says that it's so complex the way that they explain it, and I feel like to read it, it's just
But what was the thing that wound you up?
the whole thing. I can't even explain it because the more I read it, the more I was like, what? So basically, I'm
So
trying
I
to.
didn't do my homework.
So it says, for example, now. So, exhibits what Einstein called spooky action at distance, correlations between measurement performed on particles very far apart in space. So, of course, distant correlations in and of themselves are nothing surprising. For example, suppose I take a pair of socks out of my drawer, separate them, and send one off to my friend Alice in London, and the other to my friend Bob in Auckland. If my friends observe the socks, and they compare their results and discover they both have the same socks of the same colour, there is no mystery about them. The socks are the same colour because of a common cause in their shared parts, i.e. the fact that they both came from the same pair. But the correlations appearing in quantum mechanics are special because they cannot be explained in this way. For example, distant quantum correlations are typically demonstrated in a Bell experiment, in which I prepare a pair of quantum particles and send one to Alice and another to Bob, and then Alice and Bob both choose a measurement and perform that measurement on their particle. A famous theorem due to the physicist John Bell tells us that in this scenario, correlations explained by a common cause in the past must obey a certain inequality.
Oh, the inequality principle.
Yeah.
So like we have to. Let me just
Yeah,
I guess the whole point about the fact that they're measuring the same thing, because the inequality principle, I believe it states that you can't measure like there would be like the more you measure about one thing, the more accurate it would be about something else. So if we just say like moving a car, if you're trying to get the accuracy of the speed so well, like the information about, for example, the color will be like horrible.
Yeah.
Which makes sense because like if you're using different kinds of instruments, you have to like maximize for one and then use. Oh, they explained it so well in the brief history of time, but yeah, that's the inequality principle. Like if you focus on measuring one thing, the accuracy of the other thing you're measuring will diminish.
Okay, that makes sense.
But yeah, how does it have to do with the entanglement?
So this whole thing gets to, but that clears up a lot of stuff because I didn't read about the inequality like that. But it turns out that we can choose preparations and measurements in quantum mechanics which lead to a violation of Bell's inequality. So
you can measure several
this
things
seems
precisely.
This seems to indicate that Alice's decision to make one measurement rather than another has an instantaneous influence on Bob's particle and thereby affects the results that Bob obtains in his own measurements, regardless of how far apart they are. So if I measure this sock, that sock will instantly change, and therefore none of our measurements can be accurate.
I don't see because like I've heard about this before in terms of quantum entanglement, but my understanding of it back then, I guess before this came out, was that if we both have our socks are separated, if I look at my sock and I know what color it is, I instantly know what yours is.
Yeah.
That's the way it works because the particles are entangled in a way that the information that they're encoding for are interlinked. So let's say, for example, this is my circle and the entangled. If I take this piece out and I see this piece, I know exactly the shape of the other one because I know that they're entangled together and I know they have to like be interlinked together in a certain type of way. So my understanding of it before this was kind of like if we both have different particles, I know that this is red. If we knew, let's say for example, the whole thing came from a cardinal thing, I know how red this one is. I know exactly what yours is because I can like separate the information that I have from the information that originally started off with.
That's
But this one is saying that by her measuring a certain thing, so if we use it back to the car example, let's say for example she decides to measure the color of the car instead of the speed, it affects the speed that Bob measures?
Yeah, so say if like
I hear what she's saying, but I don't.
But I guess because they're entangled, right? That's the troubling part. Probably would win a Nobel Prize if we figure this out, right? But if say both of the socks are red, you decide to measure the redness of this sock via, I don't know, stripping the dye and taking out but to measure something you kind of have to defect it.
Which is the whole like
right?
inequality thing. You need to by it's like the Schrodinger's cat thing, like by checking something or by assessing something to measure something, you're interfering with it in a way that changes what it is.
Yeah, exactly. So therefore Bob's particle will change because they're entangled.
So wait, it changes in a way that now his socks lose his color?
Yeah, could be. I think we don't know how to.
No, but then there has to be like, I know it's theoretical physics, there has to be something or some evidence that they're making this out.
Yeah, I don't know. We can keep reading it. Okay. So these instantaneous, non-local influences are troubling to many physicists.
Can you read the sentence before that?
So he says, this seems to indicate that Alice's decision to make one measurement rather than another has an instantaneous influence on Bob's particle and thereby affects the results that Bob obtains in his own measurement, regardless of how far apart they are.
See, it's that part that's the part that doesn't make any sense. What Alice chooses to measure about her particle changes his own, because like I guess that's the whole thing, right? Once you actually, that's the extra step of trippiness to the whole quantum thing, is the fact that, for example, before Alice saw hers as being like red, it was neither red nor purple.
Yeah.
But as soon as she sees that, then that affects the state of the other one that we observed. But I didn't think it was because of the fact that she saw it. I didn't think it was because of the fact that she saw it, but I need to read up on these things.
Yeah. Theoretical physics is honestly something else. So basically, I think it's trying to explain. It says these instantaneous, non-local influences are troubling to many physicists. So we're not the only ones doing this. Not least because they seem strongly in tension with our understanding of special relativity. The problem is that special relativity tells us that there is no fact of the matter about what is instantaneous. To determine whether two distant events are simultaneous, we must choose a reference frame relative to which we can assess simultaneity. But special relativity ultimately says that no reference frame is preferred, and therefore there are no observer-independent facts about simultaneity.
Yes.
Now, quantum non-locality doesn't produce any observable contradictions with this relativistic principle. Since the instantaneous influences work in a subtle way, which means they are only detectable after the results of the measurements on both particles have been compared, and therefore we can't experimentally detect any preferred reference frame.
So basically you're just saying that it doesn't contradict the specialty theory of relativity, which is fine, the world hasn't broken.
Okay. But still, if the influences are instantaneous, there must be some preferred reference frame, even if observers like us can't detect it. And it's so we don't know what frame these particles are working at, is basically what it's trying to say. Because it's instantaneous, they must have their own time frame. So to us, there's no way to frame them in terms of being instantaneous, because we prefer a non-reference frame.
No,
but these particles themselves must have some reference point which they work off.
But I guess at the point of being entangled,
I guess that's what it is troubling to think that the deep structure of quantum mechanics violates such a foundational principle of relativity. This seems particularly problematic if we one day unify quantum mechanics, relativity, and a theory of quantum gravity, for it seems unlikely we'll be able to do so with two theories incompatible, blah, blah, blah. Consequently, a number of physicists have sought to understand if there is any way we can explain these distant correlations without spooky action at a distance. In order to do this, we will necessarily have to deny one of the assumptions going into Bell's theory, and most work on the topic has focused on an assumption known as statistical independence, which simply says that the state of two particles together at the time that I prepared them is independent of the later choices that Alice and Bob make about which measurements they are going to perform. So this is where I get confused. In order to do this, we will have to deny the most work on the topic has focused on an assumption called statistical independence.
you would have to deny what you're doing.
Would have to deny one of the assumptions going into Bell's theory. And most work on the topic has spoken on an assumption known as statistical independence. So I'm guessing we're denying statistical independence.
What would you just explain this? Simply
Says that the state of the two particles together at the time at which I prepared them is independent of the later choices that Alice and Bob make about which measurements they're going to perform.
So what I'm understanding from that is like she's saying statistical independence to be true would be like, these particles are what they're going to be regardless of what Alice and Bob says. But I think maybe Bell is the person who made the research principle, because I don't remember the name of the person, and he seems to be saying that what they're trying to say is like, when with what we knew before about like the uncertainty principle, if I measure the speed of the car, like the color of the car, I'm probably going to get not wrong, but it's going to be less accurate. And if I measure the color of the car to an accurate degree, then the speed is probably going to be wrong. What she's trying to say is sounding trippy, I think, again, I haven't read this, is the fact that regardless of, because of this statistical independence, not statistical independence, regardless of because of what we're thinking about quantum, it's like quantum entanglement, is the fact that these two things are going to be what it's going to be, regardless of, let's say, for example, Alice chooses to measure speed, she's going to see a certain color of the car, right? And if Bob chooses to measure red, he's going to see a certain color of the car. What she's saying is the fact that it doesn't matter what they do, what kind of measurement that they do, the other one is supposed to be less accurate. So if, without this, it would be like, if Alice measures the speed of the car, she would see, for example, red, right? Because she sees like light red. And if Bob decides to decides to measure the color of the car, he can see the speed as something, right? So if Bob focuses on the color of the car, he can see a certain red. And if Alice focuses on the speed of the car, she would still see a certain red, even though it's wrong. But what she's saying is that these two reds have to match up. Not like they have to be exactly the same depending on the preparation of the entanglement, but they would have to inform each other. And the fact that the color is informing each other, regardless of if I decided to measure speed or decided to measure color, must mean that there is some relationship there that violates the inequality principle, because like by measuring speed I'm supposed to get color that is less accurate, but someone is already focusing on color and they're going to get a certain color which must correlate with the color I get, not as in they're supposed to be the same, but supposed to be what's the word? It's supposed to be connected in some way. So if we use like the red and blue thing, if I measure my car to be a certain amount of blue, you should be able to tell me what red is, what amount of red this is. But if I focus on measuring red, that means my information about the redness should be very correct. And I focused on speed, so the information about the blueness should be not so correct. But they're both supposed to be correct.
And they're both supposed, and we don't understand the frame at which they communicate.
The frame thing is not really getting me. It's more like it's more the uncertainty thing that I feel like I find tricky. Because if, for example, it's like, okay, let's say for example, let's use the whole purple thing. To make this pot of purple, I put like 50 cups of blue, 50 cups of red, right? If I'm focusing on measuring speed, the accuracy of my color should not be good. So maybe I should think it's, for example, like 40, right? And if he's focusing on measuring just the color, he should get the exact 50. But because he got 50, I should know my answer is 50. And that means I wouldn't get 40, that means I should get 50. But if I'm focusing on the speed, I should get an accurate value for my red, but I'm not. Which is, I feel like, how she's explaining that it clashes with the inequality principle. But I don't get the whole time frame thing, because it feels like the time frame of reference is the point they got entangled. I don't know why. Maybe I'm not understanding.
But we don't know the time frame. We don't know how they're communicating, right? We don't know the simultaneous
start point. The simultaneous start point is when they got entangled, because that's how the information between them. Well, that's what I'm thinking, because that's how the information between them got connected.
But you know how? So this is how I understand. This is how I'm understanding the reference point. Is that Einstein is saying that two things cannot happen at once, basically.
What do you mean two things?
He's basically saying
the
that
theory of relativity is not that two things can't happen at once. Oh, I wish I had the book with me. It's kind of like, for example, if I asked you how fast are we going, you would say we're not moving at all. We're static, but we are moving.
But
the
someone
Earth
from
is
Jupiter
rotating.
would say that.
Exactly. The Earth is moving or rotating. So like to be able to have a reference, but that's what they mean by two things.
So
at the same time.
what is their
like,
reference? The two particles. We don't understand what reference point they're working at.
But the reference point is where they got entangled. Like I was gonna say that it doesn't seem to me like an issue, but clearly it is, because like they're writing more paper about it. But it seems like it's like, for example, the whole thing about like the Jupiter thing. It's like if we both leave here and we end up here, our start point is here.
But that's the past.
Yeah, but the past is just like how what's it called? Like how old are you today? You were referencing when you were born, which was in the past.
See, something about the reference point doesn't make the reference point being the point of entanglement just doesn't make sense to me. I'm trying to word it, but I'm trying to think. I can't. I get what you mean though. I feel like the whole thing is so tricky, but I don't know. I'm gonna keep reading. Okay.
Oh, it's not the end.
No, there's so much more to this. Okay. So.
Okay, we need to end in 3 minutes. It's so nice and sunny out.
It is. Okay, so
I guess I'm carrying my food.
where statistical independence simply says that the state of the two particles together at the time I prepared them is independent of the later choices that Alice and Bob made about which measurements they are going to perform.
Stuff.
Yeah. But it says that. So it says this assumption is clearly necessary to prove the existence of non-locality, because if we know in advance what measurements Alice and Bob are going to perform, we can just pre-program the particles with outcomes which will give the appearance of non-locality, even though everything is completely local.
Okay, that last sentence. Well,
so it's basically saying that
non-locality, local.
this is what I'm struggling to understand. So,
is that the whole thing with the reference?
I think that's what it means. It says that we think that this is so mind-blowing because we're viewing it as past, present, future. This is happening. So how are they communicating? But if we already know if we already know what this is what this thing is trying to prove, right? This page, this article. If we already know what measurements they're going to make in the future, then it'll be easier for us to pre-program the particles to act like that. So actually, the reference point should be future, present, past, and that's how the article that's what I understand from the article explaining how the future affects the past.
That is kind of articles about the future affecting the past. Have you read the Have you heard about like Schrodinger's cat?
The one, if you don't open it, then you don't know.
It's essentially that, but like you separate, it's like two things. It's like that, but two things that are separated.
So I want to say separate the cat, but if you separate the cat, then you kill the cat. But it's like
But that's talking about. Okay, how do you think it's like?
it's linked because like instead of just one object that you were trying to not visualize, and like you're not checking to see if it's dead or alive, to cause the state to be a kind of a certain state or the other. It's kind of like that, but with two entangled things, which you then separate. So when you view one, you know exactly what the other one is.
Okay.
So I guess I'm trying to understand if this article is something new or a way of talking about something we already knew about before. Because it feels like she is explaining why quantum entanglement is so wow. In terms of like once you have the particles entangled together and then you separate them, once you see what this one is, you know exactly what the other one is without these two communicating with each other in any other way. This is something that is already known. So that's what I'm thinking. Is it like it's like someone writing a new article about the special theory of relativity? Is it like a new finding or is it a new way of seeing something or discussing something?
I don't know. This is just a website article.
Because I think like there's a new way. I feel like the new way she's trying to reframe it or trying to understand it is about the present past thing, which maybe that would be what we. I know that's what we're supposed to be discussing in this one. But we discussed like insanity and bread. So I will read this for next time.
Yeah.
And remember now the other one we have a part 1 with no part 2, but this will be a part 1 and then we'll have the part 2. That's actually because like now you're reading a briefer history of time. Maybe like some stuff will be clicking for you.
Yeah.
A brief history of time.
But I feel like I've not gone to anything mind blowing yet because
In
I'm
brief
still
history of time.
because I have read
Isn't
it.
the whole thing mind blowing? I haven't read it, but I just assume the whole thing is mind blowing. But to be fair, it was
It
written a
is.
while back, so
Yeah.
maybe things that were mind blowing before aren't so mind blowing.
Yeah, I think it's just because obviously this was all written before quantum entanglement and a lot of quantum discoveries happened in the past 10 years.
I'm not telling you like when I was only 6'1". 6. Wait. When was I in 6'1"? I was 6'1" I think 16.
When they were doing the accelerator.
No, because like I remember Dr. McConnell, which was the guy from Imperial who used to teach us like maths. He was the one who introduced me to this whole world of quantum stuff, and he knew about it back then. So that was I don't know how many years ago, and I don't know when A Brief History of Time was published.
In the 2000s.
Oh, okay. They always have like it's like a okay. I guess it's not a tech, but they always have like versions or something. Like it'd be like a new edition.
Yeah, it should be fun.
Because like I know in Briefer History of Time, he definitely spoke about how like they incorporated new things that they've learned. But I guess maybe Briefer History of Time just stopped, which makes sense. It's not a textbook.
Yeah, I also think
It's like an author republishing a novel. Like I've learned some new things, so I'm gonna write it. Some people do that, but
it's so cool though. It's like
I think I read on my
it's
walk.
so
actually.
cool that physics is basically coming back to the sort of old beliefs of fate and destiny and like maybe everything is pre-planned and how like physical theorems you know how like there's this book called The God Equation that I really want to read.
Who's it by?
I don't know, but
I've never heard of it.
it's basically like there's those like theories in theoretical physics that the theory of everything will basically lead to will basically prove the existence of God, prove the existence of whether there is or isn't a
I think
God.
they talked about this in like the Briefer History of Time or something,
Yeah.
where it was kind of like the choice of, but yeah, go on.
And it's like and there's so much to understand and there's so much evidence in the room.
I don't think there's going to be say that obviously it's optimistic,
Yeah.
but I don't think there's going to be a theory that proves this movement because I do believe there's a God, so I don't
Yeah.
think like it's just it's kind of like how people talk about different things in the Quran and people didn't know this before and now there've been like theories that prove it, blah blah blah. Like it's just like it's just true. Whether there's going to be a discovery in our lifetime that proves a certain thing to be true, or maybe once we're dead we'll be like, oh yeah, they found this out. Like I don't know if you believe in a God, but like there is a God. So whether they're going to come up with a theory this year or next year or maybe even after we die, like.
But it's so cool how it's just coming back full circle.
Yeah, because like I really want to take a picture of that. Maybe that would be our thumbnail for this. Like the sentence in the Brief History of time where we talk about how the whole reason for having subjects like physics and trying to understand our world in the first place is to understand how we're supposed to live in it and understand why we're created and who created us. But people become so like specialists in like, you know, just studying black holes or whatever it is, where people, to be fair, like I guess he's not like that because he's talking about this in the book, where people forget like the whole point of doing all of this in the first place.
Yeah.
But yeah, I'm gonna even if I don't put it in the thing, I'm definitely gonna put like a screenshot of that in there because I found that so powerful because it was kind of like, yeah.
So crazy.
Of course.
Because that means that the atoms we have are entangled with atoms somewhere else, right?
That's the thing, because like when they always talk about quantum, I guess I didn't research that much, because when they always talk about like quantum entanglement, is it like an intentional thing? Like for this atom to be entangled with that atom, they have to be like, we're going to entangle, or like the preparation they talk about, like
It says
it's kind of like
together.
Exactly, it's kind of like forcing entanglement, but does it happen without us trying to force it and make it happen in
But
the first
all
place?
atoms are prepared together in size, if at some point.
Yeah, but in terms of when they say like the whole preparing thing, like when you say prepared together, I don't think it's like a random preparation. It's kind of like you need X and Y. Like if someone said prepare, I don't know, mashed potatoes, you can't just be like, yeah, the potatoes are together. Like you need to add certain and do certain things. That's what I'm saying. Are these things that would necessarily happen just if the atoms were there, or the things that we're making happen? Like you wouldn't find mashed potatoes without someone actually mashing a potato, which is what I'm trying to understand.
But that's when,
entanglement.
I guess,
Is it like
that's where
we're forcing entanglement?
the God equation.
Do you think so?
Because that's what you're saying, like who's entangling these, or how are they entangled?
That's the question, because like what they were saying about Alice and Bob, they've done something to it
Yeah,
to then
yeah.
separate it, but like I guess that's like
But I guess the answer to that, from a theological perspective, is God.
I was gonna say I don't understand what they have to do in
Yeah.
terms of for the answer to be God. Like it could just be that, you know, when the temperature is at X degrees that happens and stuff. It
Yeah.
doesn't have to be like God is the answer, if that makes any sense. Or it could be like
Yeah.
when I don't know, it collides at a certain speed or
Yeah.
something like that.
I think where the God bit kind of comes in is that the future predicts the past, which means that it kind of, so later on in the article they come to this everything all at once theory, that everything was all at once kind of predetermined, and that's why the future is now affecting the past. That's
But
how
is
they
the
explain
future
quantum
affecting
entanglement.
the past?
But that's like how we were just talking about how I don't
Predetermination is
know.
backwards though, because like if something's been predetermined, that means that before it happens it was already known. It doesn't mean that once it happened it affected what was before.
No, because-
that's my understanding of predetermined.
So it's talking about how, so like we were just talking about how they're not looking at the frame of like these atoms are entangled, and then that's how they communicate, blah blah blah, from that reference point. Reference point they're not using is the past. The reference point they're using is the future. Because if the particles know the future, then they know how to behave in the present. Whereas if they know the past,
future, they know how to behave in the present.
that's how they will simultaneously do the same thing at once, right? So it's kind of saying how instead of them, so it's actually it talks about determinism. It talks about superdeterminism in this theory. Once you read it, I think you
I think
understand.
maybe that's what the article is trying to do. I feel like you've explained. So the article is trying to not explain what quantum entanglement is, but trying to explain why quantum entanglement happens, and they're
Yeah.
trying to explain how, because like the quantum entanglement links is true, you separate
Yeah,
them and realize. But I guess the question, what this article is saying, like how is that happening? And she's saying that sorry, I don't know why I'm thinking the author of this is female. But the author is saying that
Emily
they're
Adam,
using,
yeah.
okay, so the author is saying that they're using the future as a reference. But why?
Because that's what, when we look at it from the past, it's not making sense with the theory of relativity, is what she's trying to say.
Oh, so
Whereas
we
if
have
you
to
actually-
use it. We have to
We
look
have
at
to
it
think
in
of
the future for it to make
future.
sense.
And actually, this is another thing. Obviously, I need to read up Einstein's theory of relativity. Maybe I'm not very that's on it. But in the theory of relativity, it definitely says that if you want to assume
No one fully
this,
is. Well, we understand it to a basic. Oh,
Yeah.
actually, I should speak for myself. I'm sure there's some scientists out there that would say
We don't know.
wholeheartedly no. But I'm saying for me, I read a New York. Actually, I can send you the New York article.
yeah.
And then I read a brief history of
Yeah.
time. Those are my knowledge points
But
on the topic.
basically, it talks about how if we're assuming the space-time continuum in the theory of relativity, then we assume absolute time. And if we assume absolute time, assume that everything is predetermined.
But
So
we
theory
don't
of
assume
relativity.
absolute time, because that's what
That's what brief history of time is saying. Is from what I remember.
absolute time.
Yeah.
What was the whole point? Then you can't. Wait, so speed equals distance over time. Oh yes, that is true because speed equals distance over time. Speed of light, again, I don't understand why, but I accept it. Speed of light has to be the same in like some equation. So if the speed has to be the same, either distance or time has changed. We accept time to be absolute, which is why we say distance must change. Hence the general theory of relativity. That is true. So we're assuming time to be relative, time to
To
be
be
absolute.
absolute. And therefore everything kind of links back to this predeterminism or superdeterminism of how everything is predetermined through this, and that actually there's so much that I want to cover through that, like astrology and how that kind of links with astrological influences.
Astrological influence.
I believe. Do you believe in astrology or
No.
horoscopes, child?
No.
I feel like the theory of relativity kind of explains astrology.
You're gonna have to come back on this one
Yeah.
next week because the whole thing about predeterminism, like in Islam, we have that it's called like the qadr of Allah, and like there's a book of like Leonard, which is like people think, oh, you know, if everything is already predetermined, why do I have to do anything anyway?
Yeah.
It's kind of like God already knows everything that will happen, everything that can happen, everything that will happen.
Yeah.
Whichever one you choose is you obviously doing it. It doesn't mean that it's kind of like, let's say for example, I asked you, can I throw the ball up there? And you were like, no, you can't. And then I didn't throw up there. I was like, oh, you made me not throw up there. No,
Yeah.
I just know from, I don't know, whatever we want to use, like this, blah, 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 that we'll be able to do it. It's kind of like the whole thing of like, I feel like that's why I think like the mother of Allah, because Allah knows what you're going to do, doesn't mean He makes you. And
But
the whole
He
thing
knows
about
the laws.
not even like knows that He created all the
Yeah,
laws.
yeah.
And even like but it's like the Laylatul Qadr, because sometimes it gets all tricky because I'm like, okay, if there's already like, you know, but that has everything, and then there's like separate decrees, because like on Laylatul Qadr it's like you have the decree for like of a certain period of time, which is like, you know, so I'm like, if that's already in the Lawd al-Mafruz, then what is the decree that is like changing, as opposed to something that's already? I was watching a video about it, like, you know, but I don't see how I guess. We've
I
been
think
talking
we need
for
to,
oh my
yeah.
god, it's been an
Okay,
hour.
we need to really cut it short. Time out.
Yes, time out, guys. Bye.
This really took such a time, but I have not stopped being able to think about this for like
But also,
2 years.